abnormal voltage readings, specifically 120 volts from hot to neutral, 144 volts from hot to ground, and 24 volts from neutral to ground, indicate potential grounding and bonding problems within the step-down transformer system. A primary suspect is a faulty bonding wire. This wire connects the transformer's secondary neutral terminal to the equipment grounding bus. If the bonding wire is loose, broken, or corroded, it can disrupt the proper grounding path and cause voltage imbalances. Visually inspect the bonding wire for any signs of damage, corrosion, or loose connections. Use a multimeter to test the continuity of the bonding wire. The resistance should be near 0 ohms, indicating a solid connection. If the resistance is high, clean the connections or replace the wire. An open ground conductor is another potential cause. The ground conductor, typically green or bare, runs from the transformer to the grounding bus. If this conductor is open or damaged, it can prevent proper grounding and lead to voltage fluctuations. Carefully trace the ground conductor from the transformer to the grounding bus, looking for any breaks, cuts, or loose connections. Use a multimeter to test the continuity of the ground conductor. The resistance should be near 0 ohms. If the resistance is high, repair or replace the conductor. An improper neutral connection can also contribute to voltage irregularities. The transformer's secondary neutral must be securely connected to the neutral bus in the panel. A loose or corroded neutral connection can create a voltage difference between neutral and ground. Inspect the neutral connection at the transformer and the neutral bus in the panel. Ensure that the connection is tight and free from corrosion. Use a multimeter to measure the voltage between neutral and ground at various points in the system. The voltage should be close to 0 volts. If the voltage is significantly higher, investigate the neutral connection further. Internal issues within the transformer itself can also cause abnormal voltage readings, although this is less common. These issues might include shorted windings, insulation breakdown, or other internal faults. Before suspecting a faulty transformer, rule out all other possible causes, such as grounding and bonding problems. If all other checks are satisfactory, consider testing the transformer using specialized equipment or consulting a qualified electrician. To systematically check for grounding issues, firstly, test the voltage between the neutral terminal and the equipment grounding bus using a voltmeter. Ideally, this reading should be close to 0 volts. A significant voltage reading here indicates a problem with the neutral ground bond or a ground fault somewhere in the system. Secondly, measure the voltage between one of the hot terminals and the equipment grounding bus. This voltage should be approximately 120 volts in a standard 120 volts system. A reading significantly higher or lower than 120 volts indicates a grounding issue or a voltage imbalance. Thirdly, test the voltage between a hot terminal and the neutral terminal. This voltage should also be around 120 volts. If this reading is significantly different, it suggests a problem with the neutral connection or a voltage imbalance. If unusual voltage readings are found during these tests, a systematic troubleshooting process is necessary. Begin by inspecting the bonding wire between the transformer and the equipment grounding bus. Ensure that it is securely connected and not damaged. Use a wrench to tighten the connections and visually inspect the wire for any signs of corrosion or breakage. Next, trace the ground conductor from the transformer to the grounding bus, checking for any open connections or damage. Pay close attention to any splices or connections along the way. Use a multimeter to verify the continuity of the ground conductor. After checking the grounding system, ensure that the transformer's secondary neutral is properly connected to the neutral bus in the panel. Tighten the connection and visually inspect it for any signs of corrosion or looseness. Use a torque wrench to ensure that the connection is tightened to the manufacturer's specifications. If all the external connections and wiring appear to be in order, it may be necessary to inspect the transformer itself for internal issues. This may require specialized testing equipment and the expertise of a qualified electrician. Internal transformer problems can be complex and potentially dangerous to diagnose and repair. When working on electrical equipment, safety precautions are paramount. Always turn off the power supply at the main circuit breaker before beginning any work. This will help to prevent electrical shock. Wear appropriate safety gear, including gloves and safety glasses. Gloves will protect your hands from electrical shock and safety glasses will protect your eyes from debris. Use caution when working with live wires. If you are not comfortable working with electricity, consult a qualified electrician. If in doubt about any aspect of the troubleshooting process, it is always best to consult a qualified electrician. Working with electricity can be dangerous and it is important to take all necessary precautions. In addition to the above steps, consider the following factors. Check for loose connections. Loose connections can cause voltage drops and other electrical problems. Tighten all connections to the proper torque. Inspect for corrosion. Corrosion can impede electrical flow and cause voltage drops. Clean corroded connections with a wire brush and apply a corrosion inhibitor. Look for damaged wiring. Damaged wiring can create short circuits and other electrical hazards. Replace any damaged wiring immediately. Verify the transformer specifications. Ensure that the transformer is properly sized for the load it is serving. An undersized transformer can overheat and cause voltage drops. Check the transformer's taps. Some transformers have taps that allow you to adjust the output voltage. Make sure the taps are set correctly for the application. Inspect the grounding electrode system. The grounding electrode system provides a path for fault current to flow back to the source. Make sure the grounding electrode system is properly installed and maintained. Test the ground resistance. The ground resistance should be low enough to allow fault current to flow back to the source. High ground resistance can impede the flow of fault current and increase the risk of electrical shock. Monitor the voltage under load. The voltage should remain stable under load. A significant voltage drop under load indicates a problem with the wiring, connections, or transformer. Use a power quality analyzer. A power quality analyzer can help you identify voltage sags, swells, and other power quality problems. Consult with a qualified electrician or engineer. If you are unable to resolve the voltage problems, consult with a qualified electrician or engineer. They can help you diagnose the problem and recommend a solution. Regularly inspect and maintain the electrical system. Regular inspection and maintenance can help prevent voltage problems and other electrical hazards. Keep accurate records. Keep accurate records of all inspections, tests, and repairs. This will help you track the performance of the electrical system and identify any potential problems. By following these steps, the source of the abnormal voltage readings in the step-down transformer can be identified and resolved, ensuring a safe and reliable electrical system. The importance of proper grounding and bonding cannot be overstated. A properly grounded and bonded electrical system helps to protect people and equipment from electrical shock. It also helps to prevent fires and other electrical hazards. Grounding provides a path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and prevent electrical shock. In addition to safety, proper grounding and bonding also improves the performance of electrical equipment. It reduces electrical noise and interference, which can improve the reliability and accuracy of electronic devices. It also helps to prevent voltage fluctuations, which can damage sensitive equipment. Regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. Check for loose connections, corrosion, and damaged wiring. Test the ground resistance to ensure that it is low enough to allow fault current to flow back to the source. A qualified electrician can help you inspect and maintain the grounding and bonding system. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions and following the proper procedures, you can help to prevent electrical accidents and ensure a safe working environment. Remember to de-energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, consult a qualified electrician. Stay safe and be careful.